Launch Visual Studio Code and create a new Jupyter Notebook file. We're going to name it LangGraph-chatbot.ipynb. You can choose any name you like. We're going to start by importing the required libraries. First, we're going to use LangGraph and then LangGraph_Ollama for our models, and then typing extensions request panel for our chatbot in the Jupyter Notebook, and then HTML to text to convert HTML to text for the user. Next, we're going to add the state, a central piece in a LangGraph node graph. We're going to import typing extensions, and LangGraph graph message. And this is the state definition. As you can see, it's a simple dictionary that becomes available to all nodes in a graph. Nodes in the graph can read from the state and write to the state, but all writes are performed as updates. This is very similar to the Flux pattern, where a central store is available to all components in a React app. Next, we're going to create the state graph, the graph builder itself, by passing the state object to it. This is going to hold our nodes. In the next step, we're going to add our model. In this case, we're going to use Ollama and Llama 3.2 1 billion. And this is a good opportunity to check if Ollama is working. brew services info Ollama is the command. And we can check that. Yes, in our case, our service is running. And to make sure that you have this model downloaded, you can also execute Ollama list pipe grep llama 3.2 1 billion. And sure enough, we have this model. It's 1.3 gigabyte in size. So those two are good. That means our model is defined. Next, we're going to define our chatbot node. A chatbot node, or any node, is just a function that takes the state as a parameter and returns the messages. In this case, it's a hash and the key is messages, and it returns llm.invoke by passing the state messages. This is our coding assistant, and currently the state holds a single key messages. But as I mentioned earlier, the state itself is a dictionary and we can add any keys to it that we'd like. In this case, for instance, you can add num messages, for instance, as an int, and then update it here as num messages. We'll see how to use this later when we're customizing the state, but in this step, we're not going to change the state. We're going to keep it as the default state, but just know that this is our chatbot node. That's how we're creating it, and later we're going to add it to our graph. In this step, we're going to add our defined node to the graph. And graph builder add node is the function, and then we pass the name, and then we pass the object. This is how our node will be identified inside the graph. Next, we're going to add start and end nodes. Every LangGraph node graph has a start and an end node. And there are special keywords for that in these classes and define the start and end. Add edge is a special method that defines the route that can be taken inside a graph. In this case, it starts with a start and goes to the code assistant, and from the code assistant, it goes straight to the end. So it's a straight line. But if you have more nodes and if you add more assistants, or in this case, bots, you can have different edge definitions and rules around these edges, as we'll see later in step 3. But for now, this is just defining the start and end nodes, and the add edge is just telling the graph where to start, where to go next, and how to end. In the next step, we need to compile the graph. And to do that, it's quite simple. Graphbuilder.compile. Now, let's display our graph graphically as an image on the screen. For this, we're going to use IPython display image and display. This example is available on LangChain and LangGraph's website, by the way, so you can pull it from there and display this graph in your notebook. This is also a good opportunity for us to run it up to this point and see what's being displayed. So go to the top of the notebook and select Run All. It will prompt you to select a kernel. So I'll select my 3.12.6 kernel and start running this. Okay, so we have our chart, and we can see that we have a start node. It goes to Coding Assistant, which is our chatbot name, and then it goes to the end node. So that's our very, very simple LangGraph graph. Now let's define the invoke function that will display our messages. Here, we're importing human message because we'd like to filter the last of the messages, that is the human message, and return the entire list of messages. You may notice that Graph has several methods that it can invoke messages. One is .stream. The other one is .invoke. If you use .stream, then you can stream the output to the screen in a typical chatbot interface. In this example though, Jupyter notebooks are a little tricky, so we're going to use invoke and just get the snapshot of the last message. Now let's create the UI for our chatbot. We're going to use Panel, one of the dashboard libraries for Python. Now we're going to define our elements. We'll define some input styles for our prompt input button and the text box. Next up is we define the styles for our chat bubbles. So in this case, we have two bubbles, one for the assistant and one for the user. So we define slightly different styles for them just so that we can differentiate. And here's our collect messages method that gets called to compile our panes and our rows and our columns so that they can be displayed properly. Last step is for us to define the dashboard and then display it. So the way we define the dashboard is of a column with two rows. We have our input box, our button, and then the conversation. That is just a collection of chat bubbles. And that's it. Here we display the dashboard. Now let's run this and see the outputs. I'm going to clear all outputs and then run all. And there you have it. We have our text box where we type our prompt, and then we have our chat button. So let's give it a test drive. Hello is our first message. This is from the user and this is from the assistant. Okay, great. So we have the model working and it's answering. Let's type our classic question now. So our prompt is create a React component for a sign-up form in an online banking app. And let's just wait. As a reminder, we are using a rather fast, a small and a fast model. It's Llama 3.2, 1 billion. And so the result should be okay. And now we have our React component. As you can see, we use the markdown pane here to add color coding. This is our form. This is our React component generated. Let's inspect it very quickly. It has a username field, email, password, confirm password, and errors. It's pretty good when you consider that it's a small model and it's a very generic React component at this point. Our basic chat is working and we can ask more questions or go back and forth. It even provided some styling for the form, and that's really good. And now we're in step 2. Our chatbot is working, but there's some issues. For example, it created this form, but let's try to refactor this by renaming it. So let's ask our assistant to tell us the name of this form. It's a very simple question. What is the name of the React component? And obviously it's sign up form. And sure enough, the answer is I don't have enough information to provide the name of a specific React component. And with that, that means that any changes that we'd like to request on this component, the model just simply doesn't know, because it doesn't have memory. So let's change that. Memory is basically a concept where the conversation and the history of the conversation is retained. There are two types of memory. There's short-term memory and long-term memory. For this example, we're going to use short-term memory, which usually is just kept in memory, versus long-term memory is stored in a data store such as Mongo or DynamoDB. But again, for this tutorial, we're just going to do in-memory memory for this model. So for that, we're going to clear all outputs and make a few modifications to this code. We're going to start at the top. To add memory, we're going to use the built-in classes from LangGraph. The way to do that is to use the memory saver class, and we can define memory equals to memory saver like this. We also need to add a config variable, which is simply a hash with keys in certain values. This one defines our thread ID, and that's how the graph is able to identify which one to use. In a long-term memory, the database assigns these IDs, but in this case, we can just assign it 1 or any other random number that identifies this thread, and the memory should work. So this is the first modification. The second modification is we need to change how we initialize the graph. When we do .compile, we need to now pass the memory parameter to it. So we just do checkpointer equals memory. The third modification that we need is inside the invoke graph. So basically, in the invoke method, we need to pass our config as the last parameter. With these three modifications, our chatbot now should have memory, and we can rerun it and test for whether it's working or not. We're going to restart the kernel and run all one more time. Okay, so the simplest way to test for memory is by asking for my name. Hi, I'm Bob. And immediately, hello Bob, how's it going? And then I can ask, what is my name? Just to be sure. I don't have any information about a person named Bob, including your personal details, but still it remembers my name, which is pretty good. Again, we're working with a rather small model. So back to our React question. Let's run that one more time and let's see what happens. Okay, so we have the same pretty much React component now generated with the same name sign up form. Okay, now we have memory, and let's take a look at customizing the state. The state variable is defined as a dictionary, and currently it has one key called messages. Let's change that. The first modification we need to do is actually add a new key to the state variable. So let's go ahead and add a new key, num_cold, of the type int. The second modification we need to make is in our chatbot definition. So let's find our chatbot definition method, which is right here. And we need to replace this by updating this for the number of times this is being called. So this first line actually updates the state by incrementing it by 1 and only the num called. And the return parameter then returns the num called as well so that we can use it in other nodes. The third modification will be inside the collect messages method just before we display the messages on the screen to the user. We'd like an indication to see how many times our messages have been called. So inside this method, we're just going to add this. And then we need to print the assistant label. Instead of this, we're just going to add assistant label down here. And that should take care of the displaying of how many times this particular message was called. Okay. So that's how we change the state by adding a custom variable. Okay, we're in step 3 now. And in step 3, we're going to make a few more modifications to our notebook, and it will become a much capable chatbot that we can use for coding tasks. So let's start at the top. The package definitions are the same. Here, this is where I'm using Azure OpenAI, and my keys and endpoints are already defined in the environment. But if you'd like to use your own OpenAI API keys and as well as endpoints, this is the opportunity to do so. You can just set these environment variables here. So I just commented out for now. The state is the same, so we haven't made any changes to the state. But here is the Azure model. So this is the section that we're going to use. And this is our model definition. We're using GPT-4. This is the API version, temperature, and all the other parameters. This is the important part. This is how we define the tools. This is by importing LangChain core tools and tool. And this tool is just a decorator. In this case, we're going to define 3 different tools. Our first tool is the architectural design guidelines, which is reading an HTTP location, parsing the HTML content into text, and then returning that to the model. So that's the same as I explained in the previous video. In addition to that, we have 2 new tools. One is Get UX Style Guide, which is just reading from the file system. In this case, it's reading a file called styleguide.md. The second tool here is Get Business Rules, which is reading our use case or user story from the same location, userstory.md. We put the tools in an array, and then we have another variable definition called LLM with tools, which is binding these tools, the array of tools, to our original LLM. We're going to use LLM with tools later on in the graph definition. Take a moment here to review these tools. There's multiple tools here, and this is a good opportunity for us actually to take a look at these files, what it's going to be doing. In this case, this is just reading a HTTP location. Let's just take a look at that file and see our architectural guidelines. Okay, so this is the ChatGPT generated architectural guidelines document that we used last time. So it defines what the React component should use as far as tools for data access, for caching, for some of the divs, and some of the styling. So this document is available, and our tool will then parse the document and provide it to the model. For the UX style guide, let's go to our data folder and open styleguide.md, and let's go to the preview and just take a look at this. So again, this is a ChatGPT generated user experience style guide. This is just an example that I found useful to test these sort of applications. Your company or your team may have their own user experience style guide, and it would be prudent for you to maybe try to copy and paste content from it and try for yourself with your company branding, colors, and everything. This is just a very randomly generated style guide with some random colors, but it gives the idea for a primary, secondary, neutral color, accents, font faces, spacing, so on and so forth. These are the sections that you would find in a typical style guide. So this is one of our tools. And our final tool is actually a user story. So if you open this user story and do the preview, this is a sample sign up form for an online banking app. Again, I used ChatGPT to generate this. I'll share the prompt, but it was a very simple prompt with some specifics. For example, I particularly asked to include 7 fields: first name, last name, email, date of birth, city, state, zip, and a secure password with certain requirements. So if you read up, you will see that the use case was generated quite well. For the password, rules are also 8 characters long and must contain at least one number. So this is our use case. It's a pretty short and up to the point use case generated by ChatGPT. Our business rules doc, the tool, will read this use case and again use it in the generation of the React component. So let's go back to our notebook. So these are our tools. The coding assistant remains the same. The graph builder remains the same, except here we pass LLM with tools, as I said, and not LLM anymore. So this one knows how to invoke LLMs with tools. Now this section is interesting because the tools must be added to a node in the graph, right? So everything is a node, and for this we use the basic tool node, just a class that we define. And in this case, the tool node is a basic tool node with all the tools jammed into one node, basically. So you can have as many tools as you want, but they're all going to be treated as one node in the graph. So in this case, we add node tools, and that's where all of our tools end up on the graph. Okay, so then we add the start and end nodes as well. And here again, these are 2 interesting methods. You can read more about this on the LangGraph website. But basically, this defines the rules of how the messages get routed. And the 2 edges here are from coding assistant to tools, from start to coding assistant, and inside the routing method, then the model makes a decision either to end it if there's no need to use a tool, or to route it to one of the tools if there's a need for a tool. So that way it becomes really smart. If there's no need for using a tool, it won't use a tool. And if it needs a tool, then it will then route it to one of the tools that it determines. So these 2 methods, route tools and add conditional edges, are the way we can control the flow between tools and nodes in a graph. So this gives you very fine-grained control over the routing, and you can add as many rules here as you need to for the routing between these nodes. Later on, if you start doing multi-agent systems with LangGraph, they have similar rule sets as well, but this is just a simple introduction tutorial. So this is just one way to do this. Moving down the notebook, there's the config is the same, the graph builder with the memory is the same, and then we're displaying the rest by adding a system prompt. In this case, we're adding the system prompt as one of the messages, and it's the type of system message. Finally, we just create our panel dashboard. We add the messages. Again, we're not streaming here. In this case, we're just invoking our methods and then displaying the dashboard. So if all goes well, we should be able to start from a React component that complies with our architectural guidelines, then take it a step further and then apply the UX style guides, and take it a step further and then apply the use case. We can do that in 3 separate steps. And then at the end of the tutorial, we'll do it in one shot as well. That's the notebook. Let's run it now. And here, first thing that we'd like to take a note of is that this image is different than it was before. Now the coding assistant can go between tools back and forth until it's no longer needed. And then it can route us to the end node. So this is the start node. This is the coding assistant. This is all of our tools in a single node, as I said. And this is the end node. And by the way, there is, of course, the possibility for you to define separate nodes for each tool, but that would get the routing a little bit more complicated. For this simple tutorial, we just jam them in the same tools node. So we have our prompt, and we can actually now start with our first prompt to ask for the initial React component. Our first prompt will be a React component just using the architectural guidelines. I'm just going to paste it here so that we can read it. But basically, create a React component for an online banking app called Sign Up Form. Use the architectural guidelines from this. Get help by calling this guideline and follow each architectural guideline strictly. Include every section. Not a great prompt, but it's a good starter. Let's send it. As we can see, the tool is being called. And we have our result. So let's take a look at our first component. The architectural guidelines specifically ask for GraphQL and Apollo client. So we have it. It specifically mentioned Tailwind CSS. So we have it. And if we inspect the form, we have the outermost div using flex row, wfull. So we have a fairly compliant React component with how many fields? We have a username, password, and a submit button. Clearly, we can improve this prompt, we can improve this component, but in step 2, we're going to pass the UX guidelines as a tool and see if it can take this, refactor it, and create a new React component by retaining the logic itself. Our next prompt is for the UX. And basically what it says is create a set of CSS styles and apply them to this component based on the UX design style guide. Rework the component, retain all field information. Just change the classes. Let's send this and see what the model is going to generate. Now we can see that the UX style guide tool is being called and that file is being read and hopefully it will be applied to this. Okay, so we have our result back and let's take a look at this. And as we can see, we have now new classes and we have CSS data that comes from the UX style guide. That's really good because that means that now it's being reworked properly and will comply with our official style guide. In step 3, we're going to ask it to rework it with the business logic inside the use case. So let's try that as well. So now in this step, we're going to refactor the React component based on the business rules provided, adhere to all criteria, retaining the structure, create a complete component, and so on and so forth. So let's ask the model and let's see what the result's going to be. Now it says getting business rules for sign up form. And we have our new component now. The prompt here is refactor the React component based on the business rules provided. Please adhere to all acceptance criteria while retaining the structure and styling. So create a complete component. So let's take a look at this. First of all, our user story prescribed 7 fields and we see the 7 fields here. Second of all, we have validation logic. As you can see for email, zip, even the password, we have validation logic and it says it should be at least 8 characters and contain at least 1 number. So that's really good as well. We have a handle submit and let's take a look at, yes, so GraphQL was retained. So the information from the architectural style guidelines, from the visual style guide, everything is retained and we have our new component. So let's take a look at the fields. We have first name, last name, email, date of birth, city, state, zip, and password. Everything with a style guide, styles. So everything looks almost perfect in this component. So there you go. This looks really, really good. It's a rather long file and it includes rules from our architectural style guide, architectural design guide, the UX style guide, as well as the user story for this component. So one last thing we can do here is to, first of all, execute it. Right now, what we did was we did a bit of chain of thought. In other words, we started a React component with one step, and then we took that and refactored it and then refactored it again by using 3 separate tools. And that could be a very useful exercise if you actually have working React code today or working components that you just want to add new features or remove something or fix things. And that's why I demonstrated that. But you can also potentially combine all 3 into one step. So let's see how that's going to work. I'm going to clear all outputs here and combine the prompt into one single prompt. And let's see how that's going to work. So I'm going to hit run all. So now we're going to provide one prompt with all instructions in one place for all 3 tools. And we're going to provide the prompt in one shot and see how the model is going to perform. Okay, so we have our dashboard. I'm just going to paste the entire prompt here. We're going to read it later and I'm going to issue the command. As you can see, all 3 tools are being called. And this is again GPT-4o. One quick parenthesis here is that not all models, even if they support tool calling, will be able to do this. If you're on your local Ollama server and use, let's say, some of the smaller Mistral or Llama models, in all likelihood, this step will fail. And that's why I switched to GPT-4o for this step, because it's a rather complicated step and you need a very capable model. Okay, so we have our results back. First of all, let's take a look at this prompt. It's a rather large prompt. We're asking it to create a React component based on a set of architectural guidelines from this URL. Good. Then we're asking it to follow the design style guide UX from that file. And then we're asking it to change it and follow the business rules from a use case document. Again, so let's take a look at the component that came back from this one compound prompt. And we can just immediately see that React use mutation. We have our GQL here for the mutation for the sign up user. Although it only has ID, first name, last name, email, it doesn't have the date of birth, the zip state. So that is something that still needs to be reworked. But we have the form data in a use state. That's really good. And we have a number of error check-ins here, validation in the validation form. And let's see, the password, 8 characters long and must contain 1 number. So we're retaining the use case rules here. Let's take a look at the form itself. Yes, so we see the form and we see the classes being retained. We still see Tailwind CSS and the form looks pretty decent as well. So at this point, it really depends on your patterns of use. I personally like the chain of thought a little bit, the step-by-step process a little bit. The key thing there to be careful is not to regress from the previous step and not to lose any information that was originally there. Experience from smaller models, 7 billion models, is that they usually drop fields of the file while they add new information. Larger models like GPT-4, GPT 3.5 are a lot more capable in this, as you can see, and they're capable of generating step by step, allowing you to refactor a React class as you go, as your needs evolve, or you can even pass a single shot and get a fairly acceptable React component at the end. That's it, guys. If you've come this far and been able to follow the steps in this tutorial, you should now have a coding assistant that can help lift some of the load off your shoulders. The source code of this project will be shared in a GitHub and a link will be in the description. If you face any issues during the tutorial, please post a comment and I'll do my best to answer your question as soon as possible. This wraps up our LangGraph introduction tutorial for today. I hope you enjoyed watching it and I hope you learned something new about LangGraph and function calling. Please remember to like, share and subscribe to the channel for more videos like this. Please let me know in the comment section what topics are of interest to you and I will try to make a tutorial for them. Thank you for watching.